Welcome back, everyone. We're still in programming with C++, and today we'll be treating functions. Right. So our main objective at the end of the lesson is to learn what functions are, learn how to declare and define a function, learn how to pass an argument, learn what default arguments are, learn the value return and the function names. We also want to understand what function overload and pointer functions are and what they do, and learn other user-defined functions, right? Let's get started. So when we talk about function in C++, they are the blocks of code designed to perform specific tasks, right? So they are the lines of code or multiple lines of code designed to perform a task or a specific task. They are fundamental for organizing code, promoting reusability, and making programs easier to manage. So they also are helpful or basic for organizing the code, promoting reusability, and making programs manage easier. We have types of functions. We have the user-defined functions. In my previous video, I dealt extensively with the user-defined functions, and I said they are created by programmers to perform specific tasks. So that you make it's not known in the C++ libraries, right? So you have to define it. You have to let the compiler know what it is, right? And we have the standard library functions. They are the predefined functions, and they are already available in the C++ library, such as the std, cout, and so on and so forth, right? We have the other types of functions. We have virtual functions. For the virtual functions, they are functions in base classes that can be overridden in derived classes, enabling polymorphism. So for classes, I'll be treating the in my next video, so stay tuned for it. For the inline functions, they are functions where the compiler replaces the function call with the function's code, potentially improving for small functions. So functions that are small, the inline functions help, or it's where the compiler replaces calling the function with the function codes. We have other benefits of functions. It helps in the breaking down of complex programs into smaller, manageable units. That's the modularity. It also helps in reusability. That's you write code once and use it multiple times, right? It also helps in abstraction. That's hiding the implementation details, focusing on what the function does rather than how it does it. And it improves readability. Thus it makes code easier to understand and maintain. So we begin with the function declaration. We said it's also known as a function prototype. It declares the function name, the return type, and the parameters. So this is the syntax. So first, to declare a function, you declare the function name. You first declare the return type. What is the return type? Is the data type you want the function to return for you. So you declare the return type, the data type, then the function name, which is also known as the identifiers, and your parameters, right? But if you want to define them, right, you declare these things: the function name, return type, and parameters. Then you introduce a curly braces. That's you are defining them. I'll elaborate on the definition as we move on. So for the declaration, when you just declare the function name, the return type, and parameters, and you terminate, you've declared, and that's it. Function declaration also allows the compiler to verify correct function calls. Right, so the syntax is this: the return type, the function name, and the parameters. So the return type, that's the data type you want the function to return for you, be it of the integer, the boolean, the character, or string data type, any data type you want it to return for you. Then the function name is the identifier or the name you want to give to the function. Let's say you want to add two values, right? So that will be the function name add. Then the parameters are the variables, right, that are passed on to the function, right? This is how we declare a function in C++ programming language. The return type, that's the data type, then the function name. Say you want to find the sum of two numbers, right? Then you declare those numbers or those variables too. You give it the data type and the name, and the data type and the name, then you terminate. So this is basically function declaration. And note, these functions, declarations and definitions and calling, they are all done in the global scope. In my previous video, I spoke about the global scope and the local scope. And I said the global scope is where the function is defined or declared outside of the int main. That's where the data will be entered, but it can be accessed from within the int main. But any function written or any program or statement written inside the int main, that's the local scope, cannot be accessed by what is written in the global scope. So take note of that too. For the function definition, it says it's a function declaration in which the body of the function is presented. So function definition is just a declaration of the function by defining it. You're making the body of the function known to the compiler, right? So the structure is uh, the return type, the function name or the identifier, then your parameter list, which could be optional, then your body, and it should be enclosed in the curly braces. Note any statements or program written inside of the curly brace is a body to that function, right? So this is also how we do it. So the return type, the function name, then your parameters. Then instead of terminating, you introduce the curly braces, then you give the statement to perform a task, then you return the value, right? So once we identify or know what these keywords in this function definitions are. For the return type, we say it specifies the data type of the value the function will return, as I said earlier. And you can use void if the function doesn't return the value. Void is also a data type, but it's of no particular data. It doesn't return any particular data type. It's just a syntactical data type, right? We also have the function name. It's an identifier that uniquely names the function, right? We have the parameters. So these are the input values passed to the function, declared with their types and their names. So they are the input values passed to the function, declared with their types and their names. We have the function body containing the codes that executes when the function is called. So when you call the function, uh, what will be called is what is inside of the function body. So the codes inside of the function body is what will be executed when you call the function. For the return statement or the return value, it's used to return the value back to the caller unless you introduce a void which returns no value. But if isn't any void, you use it to return or send a value back to the caller. So this is also another way of defining a function in C++ programming language. So your return type, your function name or identifier, then your parameters, you state their types and their names, right? No, the parameters are also variables, right? Then inside of the function, that's the function body, we so we tell it more want to add the values. So we can say first num plus the second num. Then we return the value. So what you are returning is the summation of those two values. But here we initialize a variable result to be the summation of those two values. So instead of returning first num plus second num, we return results. Since those the sum of the two numbers has been assigned to the variable result, that's what you return. And note this, all these are done in the global scope, right? For parameters, they are the variable in the function definition that receive the argument. So they are the variables receiving the argument. So the syntax is the return type, the function name, then the parameters. So the parameters, you declare its type and its name, right? Then your function body, then you return the value. Arguments are the values passed to a function when it's called. So they are passed to the function when they are called. And arguments are also the values assigned to the parameters, right, when they are called. So also the same way, the function name, then your argument. So this one, you don't bring the return type, you just bring the function name since it has already been declared. You just bring the function name, then your arguments, the actual values and not the parameters, right? We also have other arguments. We have references as arguments, pointers as arguments, and arrays as arguments. I treated references, pointers, and arrays in my previous video, so you can check that out and understand what these are. For the default arguments, they are the values assigned to the parameters during function definition or declaration, as I said earlier. So these arguments are assigned to the values, to the parameters. They are the values are assigned to the parameters. So we can say the return type, the function name, then the first parameter, its type and its name, then the second parameter you can assign a value to it. A basic C++ program of the default argument. So we want to get the sum of, say, two variables x and y, right? The return type, the function name, then the parameters. But we initialized, or we assigned the value 20 to the variable y. So the value 20 is the default argument and the y is the parameter. So what this actually means is that y is 20, right? That's default means it's 20. That's its initial value. Then you define it, you want to return, say, the sum of it, x plus y, then you terminate. So now continuing that, if you want the compiler to display, say, the sum of it, right, to display the function, we say get sum 5. So what this the first statement mean is that since y has already been given an argument, a default argument to be 20, we just give the variable x, which hasn't been initialized, 5. So that's what we said, get sum 5. For the second one, we are saying get sum 5 and 15, and we know y has already been initialized with the value 20, and here it's also saying assign 15 to it. So you add, so in that process it's going to display 15 plus 20, giving you 35, right? And then the value for the variable x, which is 5, then you sum it, right? Now for function calling, to execute a function, you call it by its name followed by the parenthesis on any required arguments. I'll dive into the practical session so we get a better understanding of all what these functions are. So we call it by its name, that's the function calling, and followed by the parenthesis and any required arguments. So this is basically a function calling step. So we say we call the function by its name, that's a get sum, and then the parenthesis, then inside the parenthesis we give the arguments. Note, arguments are the values assigned to the parameters, right? So we call it by its name, the function name, then the parenthesis, then your arguments. For function overloading, it defines multiple functions with the same name but different parameters. So multiple functions with the same name but different parameters. It could be used in a case where there is a need for one function but differences in parameters, right? Now we also have three different ways function overloading can be used in C++. The first is it can be used by having different number of parameters. While when you have different number of parameters, we can use the function overload. We can also use it when we have different types. So the first one is the number of parameters. See, the first you see, I treated if statements, or yeah, in my previous video, and I said we have the nested ifs. That's the if inside and another if, right? So it's inside, so it's a subset of the main if. That's how function overloads to mean the function is a subset of the other function, the main function code. So we say the first function can have, let's say, two parameters, and the next function will have three parameters. So that's what we mean by they having different number of parameters. For the different types of parameters, they can have uh, one can be of the integer data type, the double, the float, and so on and so forth. And the last one is it can be of both, it can have both different number and types of parameters, right? So this is the first case, right? The first case is having this different number of parameters. So we first define a function, then we want to overload that function. We don't change the function name, but the parameters, right? So the first function had two parameters, but the second function had three parameters, but they are of the same data type. That's what we mean by they having different number of parameters. Now for the case 2, which is the different types of parameters, right? We say they should contain the same number of parameters but have different types. So their data type should be different, but they should have the same number of parameters. As you see, the first one was of the int data type and the second one was of the double. For the last case, having both the different number of parameters and the different types, we see it in the first case, in the first function, the parameters were of different data types, and they were, yeah, different data types, and in the second function they were of different data types, and its number of parameters differs from the first function. So this is basically all what um we say about function overloading and functions. So now we dive into the practical session to understand more, to get a more understanding or a better understanding of all what this function is all about. Stay tuned. Welcome back. So we begin with the function declaration. I'll comment this, right? So commenting actually makes my program understandable, so you can understand what I'm doing. So this one, we begin with function declaration, and note we said in declaring or defining or calling or even overloading the functions, we do it outside of the int main. So I'm going to erase this. Don't forget, it should be in the global scope, that's outside of the int main. So I function, sorry, we'll start with the declaration. Right. So we say the syntax is the return type, which is the data type you want the function to return. Then the function name or the identifier. So let's say we want to find the sum of two values. So let's say find sum, right? Then inside of the parentheses, that's where we have the parameters. So the variables that are passed on to the function. So we first declare the variables that we declare their type and their name. And let's say we want to find the sum of A and the sum of B, right? So declaration, then you terminate. So this is function declaration. This is all about function declaration. The return type, the function name, the parentheses, then inside of the parentheses we have the parameters. Those are the variables pass to the functions. Then your termination symbol is the semicolon. Then you terminate. Now we move on to the function definition, right? Function, sorry, sorry. So function definition is the function declaration, but the function body is included. So you're telling the compiler more of what that function contains. So we say, since it's a function declaration, we have the same return type, then the function name, right? Then your parenthesis, then inside you give your arguments. You want to work with the first one, so A and B, right? Then now, instead of me terminating showing a declaration, I'll introduce a curly braces. That's where my function body is going to be presented to the compiler. So instead of my inside of the function body, I want to say add the values A and B. So let's just say A and B, then we terminate. So A and B have been declared already as an integer data type, so you need not bring it. So after you are done telling it what it should do for you, then you instruct it to return the value. So we want to return what the summation of A and B gives us. So in other ways, you can actually erase this part, right, and just return the value as this. Right now, if you want to instruct the compiler to display the summation of A and B, that's where we work now inside the local scope that's inside of the int main. So the cout. Now if you are to say tell program or instruct it to, or if you are writing say A plus B, what you are instructing the compiler to do is not to output the sum, but rather to output that letter A plus B. Let's run this, and let me first comment this. Let's run this to see what we get. Right, so it won't output the sum. So if you want it to output the sum, you take off the quotes, the double quotes from there, right? But first we weren't given, so this isn't going to give us any value, since we've not initialized or assigned any value to the variables A and B. So what we're going to do is we call that. Now this is where function calling comes in. We call the function by its name. Remember, call the function by its name. Then calling the function by its name, it was a function, then your parenthesis, right? So now you give it an argument. So the arguments are the values assigned to those variables. So let's say we want to give it 1 and 2. So what this means is that A has been assigned the value 1 and B has been assigned the value 2. You're just calling it and assigning values to it. So this is basically how to call the value or the function by its name and assigning values to it. So if we're to output this, we're going to get 3, because we said it should return the value A plus B. So 1 plus 2 giving us 3. Let's run this and see. Right, so this is basically all about function definition and function declaration. We can also make, instead of bringing A plus B, we can assign the summation of A plus B to another variable. So first we declare the variable, say result. We want it to be stored in results, right? Then we assign the value A plus B to it. So the result now contains what A and B will give you, the summation of A and B. So instead of you returning A plus B, you say return result, because now the summation is stored inside of the variable result, right? So this is also another way to do it. Now we move on to the function overloading, and we say function overloading is when you it can be done in three different ways. The first way was that they have different different number of parameters. So let me multi-line comment this. I spoke about commenting extensively in my previous video, so you can check it out to understand what this commenting does and what they are. Right, so we are moving on to function overloading. So first we are still working with the same function we declared. So say let me just comment this as well. So now the function overloading still is a declaration, but you are given two or more functions inside of one function. You are overloading the function. So the same return type. Then let's say this time we want to add. Let's use the variable name or the function name add. Then inside of the add we bring our parentheses. Then the parentheses we state our parameters. So let's say the parameter should be of an integer data type, and we want to add say a and b, right? So now we don't terminate, since it's actually a function definition, but you're overloading it with other functions. So after you're done with the first declaration of the first function, we can declare another function of the same return type and function name, but they'll have different number of parameters. As I said, that's the first case we're treating with the different number of parameters. So let's say int a, int b, then int c, right? So this is also how we this is function overloading. So this is the defining the function by having a different number of parameters. So the parameters are of the same data type, but they are different. The number of parameters are different for each function. This contains 2 and this contains 3, right? So we want to return the value of the first function, so let's bring the return value. We want to add them, so we return a plus b, then we terminate, right? So this for the first function. For the second function, we return the parameters, so a plus b plus c, because it contains 3 different parameters and not 2. So this is how we do the function overloading with different number of parameters. Let's try to instruct the computer to see out something. So let's say add so in the function calling is done in the local scope, right? So that's where you instruct the compiler to display something for you. So you call the function by its name, and its name is add, then your parentheses, then you give it an argument. So if I'm to give it 1, 2, the arguments it will follow the first it will assign these values to the first function, because the first function it has 2 parameters, but if I should make it 3, it will assign these values to the second function, which is this, right? So but sorry, I should have brought this over here. Right, so we run this to see what we'll get. Don't worry if you get an error actually prepares you, right? So we had 6. So this was these values were assigned to the second function since the number of parameters there differs with the first function. But let's make it just this and see what we'll get. So this is giving you the value or the return value for the first function. So this is basically all about a function overloading with a different number of parameters. Now let's say we want to work with function overloading with the second case, which is the different types of parameters. So they are having different data types. So I'm going to work on this same functions here, but I'm going to make one of its parameters a float, right? A float data type. So we said they should be of different types. That means they should have the same number of parameters but different types. Then I can make here say a double, or I can just choose to make the first one the same int, right? I leave it, then I change the second one to double, so I change all. And note you're working with the parameters are of the double data type, so you have to return the return type should also be of the double data type. So let's run this. So this is the second case saying it's of different types, right? But the number of parameters are the same, just that the types are different. So let's run this to see what we get. Right. So okay, sorry, I should have erased this since I erased the C from there. So that was my mistake. So we get a 3. So now I'm believing this 3 is working for the integer data type since a double is mostly a decimal number or figure. So let's try making it say 444. Alright, let's make them decimal numbers to see what we're going to get. So this will display the second function return value, right? So 4.222. So this one is for the second function. It's returning the value for the second function, and what I did, the 1 and 2 returns the value for the first function because the integer data type is just a set of positive and negative whole numbers, right? It's not a decimal number but for the double, it's a set of decimal numbers with double precision. So it's having a threshold is 15. That's after the decimal points, the values that it's going to contain is 15. Let's work with the third case. So the third case is of both different number of types, right? Sorry, number of parameters and different types. So let's say I make here a double. So it's different type and different number of parameters. Then let me introduce the C, right? So the number of parameters differs and then the types too must differ. So let's make this, since I made the first function, my B was a double, let me make this an integer, right? And we are good to go. But here, since C wasn't declared in the first function, you can make it an integer data type, but I want to leave it as such, right? So this is the third case, thus the value should be of an integer, the number of parameters differs as well as the types of the parameters differs. So for the first function, we said it's of an integer and a double, so we're going to make the second value a double type. Now let's run it and see what we get. So this processes or this outputs the value for the double, but we're getting 3 instead of, okay. Alright, so why we had exactly 3 is that integer data type I said is of um the set of positive and negative whole numbers is not a decimal number, but for a double, it's a decimal number with a double precision. So if I put the values for a double, right, and I'm to instruct the compiler to find the sum for me, it's going to erase the values after the point, since it's I said it should return the type. The return type should be of the integer data type. That's why we had the exactly 3 and not 3.3333, because integer data type doesn't contain decimal. But if I'm to make here a double type, right, that means it should return for me, the value should be of a double type. Let's see. Now we get our points, our decimal numbers following us. So take note of that. I made it an integer, so it erases every value after the decimal points, right? Now let's work with the second one. So the second one, it began with a double, so it's a 3 to 2. Then the notes. When you want to display something, we don't bring the addition symbol. The addition symbol should be done inside of the function definition, right? So that's where you're telling it that it should return this value, right, to that function. But in the local scope, or yeah, if you want to this one, you're assigning the values to the parameters. So these ones are the arguments, they are the default arguments, and you're assigning them to the parameters, right? So now let's try displaying this and see what we get. Right, 11.102. But if I'm to make the return type an integer data type, let's see, it's going to erase all the values after the point, right, as I said. So if you want the values or the values after the point to be, yeah, if you want the values after the point to be displayed, then use a double or the float data type. Thank you for watching. This is all about functions overloading, function calling, function definition and declaration. Thank you for watching. Please don't forget to like, to subscribe, and turn on the notification button to be notified when I upload a video. Stay tuned for my next video. See you. Bye.